Algebra 1, Section 3-4, Ratio and Proportion. As I make this video, it is September 11th, and just to project out, you're probably not going to get this lesson for like 3 or 4 weeks, I'm sort of guessing. So I should share this notes sheet with you when the time comes. So if I don't, somebody let me know, email me or whatever, because I would give you this as a Word document that you could just print out. This is a note sheet that I've used year to year, and I just have pasted it into my starboard here to write on. But if you want to have this as notes for printout, and I didn't give it to you, let me know. Anyway, so a ratio, a definition here. A ratio is a comparison of two numbers by division. You've probably seen both of these representations before. The colon notation, A colon B, or the fraction notation, A over B. Of course, this is a math class. We're going to tend towards the fraction, not the colon. So get used to the fraction. It's going to be more useful. Then we have another definition, a rate. A rate is a ratio between two numbers that have different units. Okay. Now, in reality, I think of rate and ratio as being different things. Okay. Whereas as these two definitions say that a rate is a certain type of ratio where they have different units. Okay. So think of something like feet per second, or pizzas per day if you work at a restaurant or something like that. Those are rates where. To me, a ratio is things that are the same, right? So if I have 22 pens and you have 3 pens, there's a ratio there, 22 to 3, where the units of pens would kind of cancel top to bottom in the fraction. We're going to see a little bit of that going on later in this lesson. Okay, so again, book definitions are what you're seeing here, but really I think of a rate as something different than a ratio. A rate has different units, a ratio has the same units, which can drop off. Okay, then there's such a thing as a unit rate where the denominator is 1. Okay, so there's the example that I'm giving you is miles per hour. If you traveled 90 miles in an hour and a half, you wouldn't necessarily tell someone that. You would just say we averaged 60 miles an hour, right? So that's 60 miles in 1 hour. The denominator is 1. Okay, and then an example. It says florist A sells 2 dozen roses for $24.60. Florist B sells 6 roses for $7.50. Which florist has the better deal per rose? So this kind of gets at the point right away of a unit rate. So one florist is $24.60 or 24.6 for 2 dozen roses, which would be 24. Another florist is $7.50 for 6. And if you divide 24.6 by 24, I think you're going to get 1.025. I'm going to double check on my calculator because I don't want to make a mistake. Yes, 1.025, meaning it's $1.02 for a rose, whereas the other one is $1.25. So per rose, which one is better? Florist A is better, right? Those are unit rates. That's $1.02 per rose. That's a unit rate. $1.25 per rose for this second florist. Okay. And what we're working towards here is being able to solve proportion problems. A proportion is simply fraction equals fraction. It's as the book defines it, is an equation that states that two ratios are equal, two fractions are equal. Fraction equals fraction. And when given a problem like this, you've probably heard this term before: cross multiply and divide. Cross multiply and divide. And that works here. I don't like that terminology, and I'll explain, and I'll show you an example next why I don't like that. But it certainly does work here. It's interesting, you'll never find the term, I have never found the term cross multiply in a textbook. I've seen them call it cross products. I've seen them call it the means extremes property, but they don't call it cross multiply. And I think why, I have a guess as to why. And I think why is this. If you are given a fraction multiplication problem, I think we've even done this in class. I think I've even covered this in a video before. You could multiply first and get 6 24ths and then reduce that fraction. But what a lot of people will do is go, okay, 3 and 3, I know that's going to cancel to 1. 2 8ths reduces to 1/4. And you get the reducing done first, and then you can immediately get 1/4. Now, I'm bringing this up because I think a lot of people think of this as like cross multiplying because there's something going on across and you're multiplying. But this is not cross multiplying. This, you might call it like cross reducing, maybe would be a better word for that, but it's not cross multiply. Okay, so to not confuse two things, I believe books shy away from the word cross multiply. But that being said, I know you've heard the term, so why would I not bring it up? True cross multiplying happens across an equal sign. That's what we're going to do in this situation. It's what you do in the proportion, cross multiply. Okay, and why would you do that? Well, because we're trying to get x by itself, so you want to multiply the other side by 8. Okay, and when you cross multiply, you're going to get 6x, and you set them equal to each other. 8 times 5 is 40. You multiply the numerator of one by the denominator of the other, the numerator of one by the denominator of the other, and set them equal to each other. Okay, and then you can divide by 6, and 46 is a fraction that reduces to 20/3, and I like that answer right there, 20/3. If you go to calculator and you change it to decimal, you better make sure that you give me the exact answer, right, with using the Repetin bar correctly. It would just be easier if you would just give me a reduced fraction, unless, of course, I tell you differently. If I say on a test, round to the nearest tenth, then you can do that. Okay, I never mark an exact answer wrong. If you give it to me exactly, if you give me the decimal form and you use Repetin correctly, but better yet, just leave it as a fraction unless otherwise directed. See that it's our textbook that uses the term cross products for that, but again, I know you know the word cross multiply. So here we go. Now, again, cross multiply and divide. I don't like that term because it's not that simple. On a problem like this, you wouldn't just cross multiply and then it's a simple division and you have the answer. No. Yes, we are going to cross multiply, and when you do this one right here, that's 10 times the quantity x plus 2. And I'll go ahead and distribute that. So that would be 10x plus 20. If you think that you might forget to distribute, then maybe write 10 parentheses x plus 2 and have an extra line of work. Never sacrifice accuracy for a little bit of paper, right? If you need to write it out, write it out. And then the other one would be 14x. And now it looks a lot like a problem that we saw in the previous lesson. So subtract 10x from both sides, and you'll get this. Divide by 4, and you'll get x equals 5. Okay. Incidentally, you think we could check this? Oh, I don't want to use my eraser. It's going to erase the equal sign. Could we check this? 5 plus 2 is 7. 7/14 is 1/2. 5/10 also 1/2. It checks. Okay. Could we have checked the one above? Certainly. Take your calculator and take 20/3 and divide it by 8 and see if it's the same as 5/6. It will be. One more cross multiply problem. Here you distribute in both ways. You're going to multiply here, and you're going to have 3w minus 12. Here you're going to multiply by 5, w plus 6 by 5, and you're going to have 5w plus 30. And most people would choose to subtract 3w from both sides. Yes. So subtract 3w from both sides. So 2w on the right then. And then subtract 30 from both sides, so negative 42. And then finally divide by 2, put the variable on the left, and w is equal to negative 21. Okay, let's check that one. 3 over negative 21 plus 6, wondering if that's equal to 5 over negative 21 minus 4. Negative 21 plus 6 is negative 15. 3 over negative 15 would be negative 1/5. Negative 21 minus 4 is negative 25. 5 over negative 25 is also a fraction that reduces to negative 1/5. It checks. Only one number is the solution, and we found it. It's negative 21. Okay, and then finally, I want to do this kind of problem. This is your fun problem here. The fastest recorded speed of an eastern gray kangaroo is 40 miles per hour. Everybody knows that. What is the kangaroo's speed, though, in feet per second? So look, 40 miles per hour, which is often represented like this, 40 miles/hour, or maybe if you have abbreviated miles per hour before as mph. The way we want to model this in algebra for a problem like this, though, is 40 miles over 1 hour. That's a unit rate, 40 miles over 1 hour. Okay. Now, I should say that there may be some conversions in the homework that you don't know. I'm going to use one right now that probably not everybody has memorized. There are 5,280 feet in a mile, okay? If there's another conversion that you need, it is available to you and in your textbook on page 778. If I wrote that down correctly, page 778 has some conversions that you may need from one to the other. And why would we do that? Well, look, because if I multiply by a fraction that incorporates 1 mile and 5,280 feet, I can convert this from miles to feet, which is what they asked me to convert. And then I could convert from hours to minutes. And then I could convert from minutes to seconds, because that's also something that they asked me to do. All right, now here's the big thing. You ready? 5,280 feet and 1 mile are the same distance. So when I write these as fractions, really I'm writing it as a fraction that's equal to 1. When you take a quantity and divide it by itself, that's 1. You know, 3 over 3 is 1. 1,000 over 1,000 is 1. -2 over -2 is 1. When you divide something by itself, other than 0, when you divide something by itself, it's 1. And this is the same length as this. So this fraction is 1. This fraction is 1. You have to decide which one to use. I'm going to multiply here by one of these two fractions. Take a minute and think. If you want to take more than just a second, pause the video. Which fraction will I choose? It's this one, okay? 5,280 feet over 1 mile. The reason that it's this one is because I want miles to cancel. Miles in the numerator, miles in the denominator. So for that reason, it's 5,280 feet in the numerator, 1 mile in the denominator. Okay? And I'll just do all this at once now. How about 1 hour over 60 minutes? Also a fraction that's equal to 1. It's the same amount of time. This amount of time and this amount of time are the same thing. This fraction equals 1. Also, we'll multiply by 1 minute over 60 seconds. And to put this all together now, if this hasn't totally made sense to you, this is why we did it this way, because miles and miles cancel. Because hours in the denominator cancels with this hours in the numerator. Because minutes and minutes, because they're in opposite places, one's in the top and one's in the bottom, numerator and denominator, they cancel, and you're left with feet in the numerator, seconds in the denominator. Okay? They wanted feet per second, and that's what we now have. So the last thing to do would be to multiply all the numbers. Notice none of the numbers cancel. This is 40 times 5,280 times 1 times 1. This is 1 times 1 times 60 times 60. And I am reaching for my calculator now. And I do get 58.6 rep 10. All right, now I just said in a previous example, unless otherwise directed, you want to leave it as a fraction. But here's the thing. If I left this one as a fraction, in fact, I'll even tell you what it is. It's 176 over 3. Okay. Now, would you tell your friend or your teacher or your parents, hey, did you know that the eastern gray kangaroo can run as fast as 176 thirds feet per second? You wouldn't say that. It's about, it's 58.6 rep 10, or approximately 59 feet per second. Okay, so it makes sense in this problem. We're very good at writing when we write tests to tell you what to round to if we want it rounded anyway. So the default would be to leave it as a fraction. In this one, because it's feet per second, obviously decimal makes sense. And you could even round here again when it's essential to know. We'll tell you. I'll tell you on the test what to round to or to leave it, or if I don't tell you, then you leave it as a fraction. All right, the video is long enough. Thanks for tuning in.